Section 2.7 is on solving linear inequalities. And at the top I have review your inequality symbols from Chapter 1. Less than, greater than, less than or equal to, or greater than or equal to. These are what we call our inequality symbols. An inequality is a statement that contains one of these inequality symbols instead of an equal sign. So it is a statement. You know, if I had 2x plus 3 equals 4, this would be an equation. If I have instead of an equal sign one of my inequality signs, then this is called an inequality. Okay? As far as solving the inequalities, it's exactly the same way that you would solve an equation. Okay? But there's just something a little bit different about the solution that we're going to talk about in a few minutes. When we have inequalities, this doesn't mean that there's just one solution or one number that's a solution. Okay, there are actually, multiple solutions. So look at part 1. It says graph inequalities on a number line. Example 1, it says to graph x is less than 5. Okay, well just think about what that means for a minute. X is less than 5. So what's a number less than 5? Could be 4, could be 3, could be -10. Okay, it's not just one number, but it's a whole group of numbers. So this is why we use a number line a lot of times to graph inequalities. Now think about, I'll put 0 in the middle. Where is 5 going to be? You don't have to write every single tick mark. Okay, I would just say, okay, I know 5 is out here to the right of 0. Just kind of give yourself a marker that you know where it is. Okay, and maybe I'll put 10 out here a little bit further. I'm going to shade all of the numbers that represent the numbers less than 5. So what's less than 5? Which way do I shade? To the right or to the left? Okay, less than would be everything to the left of 5 on the number line. And you shade all the way to the end to indicate that there are infinitely many numbers less than 5. It doesn't just stop here, it continues. Okay, then we have to put a symbol at the 5 to show that x is only less than but not including the 5. So we use a parenthesis, and it's open to the direction that I've shaded. So I know when I look at this number line, oh, this means that my variable x is less than 5 but doesn't include the 5. Okay, so you're going to use a parenthesis anytime that your problem has either less than or greater than as the inequality symbol. Okay, that just means that it does not equal the number that's written in the inequality, but rather everything less than 5. Okay, number 2 says to graph x is greater than or equal to -1/2. So again, on my number line, I'm not interested in you writing every single little tick mark. Okay, but let's say, where would -1/2 fall between 0 and -1? Okay, -1/2 would be right here in the middle. Remember, our negative numbers are to the left of 0, and they count down. So this says x is greater than or equal to -1/2. If it's greater than, then it means I'm going to shade to the right. All the numbers to the right would be greater than -1/2. Okay, but we have this little or equal to line underneath. So I'm going to have to put a different symbol than what I had here with the 5. When it includes the number, we use a bracket. Okay, so you're going to use a bracket every time that you have less than or equal to or greater than or equal to. So if it can equal that number, That bracket on the number line indicates that. When I look at this, then I know this means, okay, x can equal negative 1/2 or anything above negative 1/2. So with inequalities, we say when we're solving them, we don't have just one number that's a solution, but we rather have a whole set of numbers that's the solution that we call the solution set. Okay? So let's look at number 3. It gives you an inequality. X minus 6 is greater than or equal to negative 11. And so it says to graph the solution set on a number line. Well, we've got to solve it. Okay, treat this exactly like it's an equal sign. So if I wanted to solve it, that means all my variables have to be on one side, all my numbers on the other. So I would want to move the 6 over, just like we do with the equation. When I move it over, it's going to change the sign. So it's going to be a positive 6. So x is greater than or equal to negative 5. So this would actually be my solution set. Okay, if I want to graph it on the number line, negative 5, let's say negative 6, negative 4 would be on the right. I would just put, where would they be between? Negative 5 would be between these two numbers. Okay, x is greater than or equal to. So which way do I shade? If it's greater than, we shade to the right. And then what symbol would I put at the negative 5? Okay, because it's or equal to, I'm going to use a bracket. Okay, so this would be the correct graph. Notice at the bottom of the page how I have typed that there are 2 ways that you can write your solution. The first one is what we call set notation, and the second one is what we call interval notation. And I'll explain these two on the second part of the video. Okay, so we're just going to stop right here where we left off.